In this example, we want to evaluate the expression cosine of 27 degrees minus the sine of 63 degrees. Now, neither of these are values that we know on the unit circle, and they're not nice values that we can use like a sum or difference formula, half angle formula, anything like that. But one thing that we might recognize is that 27 and 63 are actually complements of each other. 27 plus 63 is 90. So because of that, we can use the complementary angles theorem. What this tells us is that I can change one of these to be its cofunction of the complementary angle, and that might help us in solving this. So I'm going to change the cosine to be sine. So I know that the cosine of 27 degrees is equal to the sine, its cofunction, of the complement of this angle, 90 minus 27 degrees. 90 minus 27, that's just 63. So this is the sine of 63 degrees, which means that cosine of 27 can just be rewritten as the sine of 63. So this is really just the sine of 63 degrees minus the sine of 63 degrees. And when you subtract something by itself, whoops, you get 0. So these just cancel and we end up with 0. So again, we want to evaluate this expression. Similar to the last problem, both of these angles are not values that we know from the unit circle. They're not nice angle measures to use a half angle or sum or difference formula. So we want to use we're probably going to look and see if we can use a complementary angles theorem. And sure enough, 37 plus 53 is 90, so these are complementary. So we can use the complementary angles theorem. I'm going to change the sine to be its cofunction, which is the cosine. So the sine of 53 degrees is equal to the cosine of its complement. So 90 minus 53. 90 minus 53, that's 37. So this is just the cosine of 37 degrees, which means that this whole thing turns out to be the cosine of 37 degrees divided by, so we change the sine to cosine, the cosine of 37 degrees. Anytime you divide something by itself, you get 1. And that's how you use the complementary angles theorem.